All right, ladies and gentlemen, welcome to Geometry 1, Section 1.5, Angle Relationships. I hate to break this to you, but this section is a doozy. A lot of big information in here, stuff we're going to use the rest of the semester. So if you've been kind of not paying attention so far, you might want to start paying attention with this chapter, okay? So by the end of this section, you should be able to identify and name several different angle relationships. You need to be able to use angle relationships to find missing values for angles. You also need to be able to use angle relationships to set up and solve algebraic equations. So let's start off with a little bit of vocabulary. So the first vocabulary word I have for you is adjacent angles. And if you know what the word adjacent means, it just means next to. So adjacent angles are two angles that are basically right next to each other. For the technical definition, they share a common vertex, and they also share a common side. So let's take a look at what that might look like. Here I've got two angles. They both have the same vertex. They both have point B as the vertex, and they share ray BC as a common side. So these two angles are indeed adjacent, just right next to each other. Let's take a look at what is not adjacent angles. In example A, angles 1 and 2 have a common vertex. However, they do not share a common side. So these two are not adjacent angles. Angles 1 and 2 here, they have the same vertex, and they share this common side, this vertical ray. However, adjacent angles should never overlap each other. So that disqualifies this because they do overlap. Example C, they've got a common side, but you can see angle 1's vertex is at a different place than angle 2's. Option D, they have the same vertex, they share a common side. That's the only example that does exhibit adjacent angles. Okay, so it's important to know what they are. It's also important to know what they're not. Next vocabulary term, complementary angles. Complementary angles are just two angles or two or more angles that add up to 90. It happens so frequently in geometry that we had to give it its own vocabulary term. So here you can see these two angles right next to each other. So this one's 30, this one's 60, adds up to 90. So these are both adjacent and complementary. These two angles over here, the 40 and the 50, they're not adjacent, but they do add up to 90. So they are complementary. Now, along the same lines, some angles don't add up to 90, but instead they add up to 180, and it happens so frequently that we had to give it its own vocabulary term, and that's supplementary angles. So supplementary angles is two or more angles that add up to 180 degrees. So here's a couple examples. This one's 60, this one's 120. Together, they make 180. However, more importantly, you're going to see situations like this, where you have adjacent and supplementary angles. So in this case, angle A plus angle B add up to 180, and this makes them supplementary. And just kind of a heads up, this situation, where when you put the two angles together, they end up making a straight line, that's going to be something called a linear pair. But we'll get into that in a little bit. Vertical angles. Now, most of the time when you hear vertical, you think of like straight up and down. But that's not what this means in this case. Vertical angles are two angles whose sides are opposite rays. Now, what does that mean? Let's take a look here. So here I've got two angles, angle 1 and angle 2. They share the same vertex, which is why they're called vertical, because of the word vertex, not up and down. And so you can see this top ray in angle 1 is the same as the bottom ray in angle 2. Likewise, this bottom ray in angle 1 is on the same line as this top ray in angle 2. That's what makes them verticals, when they're directly across from each other. Over here in this right diagram, you can see two sets of vertical angles. The ones with the purple dots are vertical to each other, and the ones with the teal dots are vertical to each other. Again, vertical does not mean up and down. It just means They share the common vertex, and they're directly across from each other. So here's an example of what vertical angles is not. Here in this case, angle 1 and angle 2, they share the same vertex. However, this side, the top ray of angle 1, does not make the bottom ray of angle 2. So because of that, angle 1 and angle 2 are not vertical angles. Similar idea right here. This top ray for angle 1 does not make the bottom ray for angle 2. So these two things are not vertical angles. Some people might say, well, they look like they're directly across from each other. They're somewhat across from each other, but not directly across. So don't be deceived. Last vocabulary term, we mentioned this earlier, linear pair. The word linear describes a line, and pair is obviously two things. So a linear pair is quite literally a pair of angles that make a straight line. The technical definition is a pair of angles whose non-common sides are opposite rays. That's just a fancy way of saying that they make a straight line. So here's an example of it. Angle 1 and angle 2 are adjacent, and together they make line CO. So because there's a straight line, angle 1 and angle 2 are a linear pair. In this diagram, there's several examples of linear pairs. Angles 1 and 2 are a linear pair. 2 and 3 together make up a straight line. 3 and 4 together make up a straight line. And angles 4 and 1 make up a straight line. So there's actually 4 sets of linear pairs in this one diagram. So that's it for the vocabulary. Now let's talk about what a few of these things mean. So let's talk about vertical angles and linear pairs. Let's start with the vertical angle theorem. The vertical angle theorem says that if two angles are vertical angles, then they are congruent. So here I've got an example of two vertical angles, the 65 and the x. So the vertical angle theorem tells us that if this angle over here is 65, then this angle over here is also 65. That's one of those things that's going to come in very handy throughout the rest of the semester. So make sure you understand vertical angles. The linear pair theorem. Linear pair theorem says that if you have two angles that are a linear pair, that they add up to 180. They are supplementary. And doesn't that make sense? Because if you go from one side of a line to the other, it's a complete 180 degrees. So if angle DBC is 121, that means angle DBA has to be 59 degrees, based off the linear pair theorem. Okay, so let's take what we just learned with vocabulary, the linear pair theorem, and the vertical angle theorem, and let's run through a couple examples real quick. So these first couple examples, and I don't think we'll do all of them, but says name the relationship, complementary, I'm going to add supplementary in there as well, linear pair, vertical, or adjacent. So with this example right here, angles B and A, they're adjacent because they're right next to each other. They are a linear pair because together they make up a straight line. And all linear pair angles are supplementary. Let's take a look at this example over here. So those two angles, they share the same vertex, so they are adjacent. It's not a linear pair. It's not supplementary. It's not complementary. It's not vertical. I think we're just going to have to go with adjacent on that one. If we take a look at this example, that red box in there tells me that that's a right angle. So I know that this is 90 degrees right here. And since this is a straight line right here, If that part's 90, if I take 180 and subtract 90, that means between angles B and A is also 90 degrees. So here's what I know about angles B and A in this case, is that they are adjacent. And because they have to add up to 180, they are complementary. Let's see, it's not a linear pair, they're not vertical. I think that's all we can say about that. Let's take a look down here at this example. Angles A and B, they are not adjacent. They are not supplementary, not complementary. At least there's no evidence that they're complementary. They might be, but no way of telling. The only thing I can say is that they're directly across from each other, so they are vertical angles. So very important that you can know all 5 vocabulary terms and be able to spot them depending on what the diagram looks like. Now let's use the vertical angle theorem and the linear pair theorem to figure out a few calculations here. So here I know that this angle is 50 degrees. So based off of the linear pair theorem, which says that 2 angles that are linear pairs are always supplementary, I know that these 2 angles have to add up to 180. So if I take 180 and subtract the 50, then I know that angle B is 130 degrees. If I take a look at this diagram here, this angle is 43 degrees, and this angle over here is a vertical angle with that. So we should know from the vertical angle theorem that if 2 angles are vertical angles, they are congruent. So if that angle is 43 degrees, that means this angle is 43 degrees. And something interesting I had a student tell me a while back, the way they remembered vertical angles is if you draw 2 intersecting lines, it looks like a V and an A for vertical angles. I don't know if that helps anybody, but if it does, it was worth the 30 seconds it took to do that. All right, let's look at this last example here. Because I see that red box there, that tells me that this angle is 90 degrees. So I know that angle B and the 63 have to add up to 90. So if I take 90, subtract 63, it tells me that angle B is 27 degrees. So make sure you know how to use the vertical angle theorem, the linear pair theorem, in order to come up with these answers. Similar idea right here. That looks like a linear pair. So I just take 180, subtract the 35, and I get 145. Same deal right here. 49 and angle B are linear pair. So 180 minus 49 is 131. So angle B is 131 degrees. Once you get the hang of this, this should go fairly quickly. Here I've got 2 vertical angles. So if this is 73 degrees, that means this has to be 73 degrees. Piece of cake. Last concept. Let's use what we know about the vertical angle theorem and the linear pair theorem, and let's set up some algebraic equations to solve them. So here in this first example, I can see that these two angles that have information on them make a straight line. That means they're a linear pair. It means they're supplementary. So I know that 3x plus 18 plus 93 equals 180. Make sure you know how to set up an equation like that. Linear pairs will always add up to be 180. Let's find our like terms. Subtract the 111. Divide by 3. And you get x equals 23. Next example. I see that red box that tells me that that angle is 90 degrees, which means that angle is 90 degrees, that angle is 90 degrees, but most importantly, this angle right here is 90 degrees. So I know that these two angles add up to 90. 6x plus 2 from one angle plus the 40 degrees over here equals a grand total of 90 degrees. So 6x plus 42, subtract the 42 from both sides, divide by 6, and you get x equals 8. Again, once you get the equation set up, and the more you do it, the better you'll get at it, then the quicker it'll come. All right, in this last diagram, we have to solve for both x and y. So what I notice here is that this 67 and the 4y plus 3, those are vertical angles. So I can set up 4y plus 3 equals 67. Subtract the 3. Divide by 4, and I get y equals 16. For x, the only clue I have is this red arc right here, which you should know means it's going to be congruent with another angle with the same red arc. So I know that 3x minus 2 is congruent to 67. Add the 2, divide by 3, and I get x equals 23. So make sure you know how to identify a relationship just by how the diagram looks. You can use it to figure out missing angle measurements, and you can also use it to make algebraic equations and solve those. Now, this was a lot of information, and so we're probably going to take 2 days to work on this. So you guys will have lots of time to ask questions, and if you have anything else that you want to bring to my attention, please feel free to email me or ask me in class. I will see you guys real soon. Take it easy.